All right, so 5-4, polynomial long division. Okay, we have done division of functions, but it's only been with a monomial. Okay, or it's been something like super simple, and I'm just asking you to, give me the domain, et cetera, et cetera. But this one, we're actually going to go through and divide out the like an actual polynomial, like two polynomial expressions. Okay, so you guys are going to be able to divide polynomials using long division. So please make sure you get down the goal on top of that first page. On top of that first page where it has that goal line there. Okay, so do you remember how to do long division, like basic long division? Okay, so if I have 72 divided by 12, what went under the division symbol?
No, the 72.
The 72, okay? The 72 went underneath the division symbol, and what went on the outside? 12. And then you had to ask yourself what? Does 12 go into 7? Does it go into 7? Does 12 go into? Yes, it does. How many times?
Okay, so then you put a 6 on top of here, right?
6. Okay, so then you put a 6 on top of here, right? And then what would you do?
So how would I get 72 down here?
So, well, how would I get 72 down here? I have to multiply 12 and 6 together, right? So then you get 72, and then you always subtract it. And then you would have a 0. Okay? So what goes on the inside here? 254. What goes on the outside? And then you ask yourself, does 3 go into 2? No. Does 3 go into 25? How many? 8 times. And then what did you do? You put the 24 on the 25, and you got that from multiplying 8 and 3. So then you subtract it, and you have a 1, and then you will bring down the next number, and then you ask yourself what? How many times does 3 go into 14? 4 times. 4 times 3, which gives you 12, and then you would subtract, and then you have 2, and then you would add a decimal point, add in zeros, or like a long time ago, you used to just do, remainder was 2, right? Same, I'm glad this concept hopefully hasn't left you all, okay, because you are going to need to divide polynomials. What about this one? Inside? Outside? Okay. How many times does 2 go into 8x squared? Just 4? 4x squared. What's 4x times 2? Sorry, 4x squared times 2. 8x squared. You subtract, and you have 0 as your remainder. This is the same concept that you will use to actually divide polynomial expressions. Okay? So, let's get into it. All right? Just to make sure, when I use, there's certain names for every piece. Okay? First off, the number on the outside is called the divisor. Okay? So instead of me saying, hey, what goes on the outside, I'm going to ask you, what is the divisor? And you need to know that's the number that's on the outside of the radical symbol. Okay? The number on the inside is called the dividend. Everyone say dividend? People like talking about, old people say, I got to collect my dividends. Nope. Okay, never mind. Extra credit for anybody who named that movie. No? I got to. No, see, no, you're asking the specifics. I got to, so that I can sit back and collect my dividends. No? Oh my God, y'all don't watch movies? Okay, here we go. Ottawa. Y'all never? It's a movie with Andre 3000 and Big Boy. Oh my Lord. Outcast? Y'all have you heard? Okay, never mind. Well, keep it moving. Has Paula Patton in there, Vin Rames. Who else is in there? That is your generation. It came out when y'all were, after y'all were born. Never mind, forget it. Just forget it. Just forget it. Oh my goodness. Okay, here we go. The number at the top. The number at the top is called the quotient, okay? So what you get, I'm sure I spelled it right. What you get when you actually figure out, how many times does 3 go into 10x squared, that's called your quotient. And then, of course, whatever is left over is called your what? Remainder. I like culture, boy. Okay. Huh?
Why are you supposed to usually know about stuff like that?
This is the same one who never heard a Trey song bottoms up though. All right, here we go. This is funny because I got all this on video, and it's still recording, so it's perfect. All right, so those are the pieces. Okay, so when you hear me refer to them, these are the pieces that I'm talking about. Okay, but you can always check to make sure that you got the correct answer when you're dividing, especially with polynomial expressions. Is you just take the quotient, multiply by the divisor, and then add the remainder. And it should equal the original dividend. So the original problem that you were trying to divide. So your quotient, which is 3x squared, times your divisor, which is 3, times plus your remainder, which is 1x squared, should indeed equal the original dividend. What's 3x squared times 3? And what's 9x squared plus 1x squared? 10x squared. Okay? Questions? All right. Now, there is a certain way that you write this, okay? Your most basic way is of course, you always write your quotient. So what you get when you actually divide the dividend by the divisor, dividend by the divisor. And then, of course, your remainder. This is all old school, okay? Very old school. No, you always have a remainder, especially with polynomial expressions, okay? However, do not write it this way, okay? This way on the left is discouraged. How you should write it is as a polynomial expression. You write the quotient, and then you look at the remainder. If the remainder is positive, you put a plus. If the remainder is negative, you put a minus. And you write it as a fraction of your remainder over your divisor. That is the proper way to write the answer of a polynomial expression when you divide it. So your quotient plus your remainder over your divisor, or minus your remainder over the divisor, depending on what the sign is. Yes, the x squared, there's your remainder. So it's always your remainder over your divisor. So anytime you have a remainder, that's how you should write that part. Questions? So before we actually jump right on into a few things outside of the terminology and outside of checking to make sure that your answer is correct and how to write it that you guys need to know. First off, the polynomials must be in standard form. Okay, we talked about standard form before with quadratics. It should be in decreasing degree. Okay, so if you have an x to the fourth, it should follow by x to the third, followed by x to the second, followed by x, followed by your constant. Okay, it should always be in standard form. And all terms must be included. You see how I went down the line with x to the fourth, x to the third, x to the second, x, and then your constant? If anything is missing, you always need to write like a placeholder. Okay? So for example, if there isn't an x to the third term, then you need to write 0x to the third. You need to have a placeholder for that missing term. If the square term was missing, you would have put in a 0x squared. If the x term is missing, you put in a 0x, and so on and so forth. Does that make sense? Okay? Then you just repeat the process of dividing, multiplying, and subtracting until you have no more divisions. All right? Just like how you would if it's old school long division. And to help make things look nice and neat, it's nice if you put like the x squared term above the x squared or the x term above the x, okay? That way you kind of won't get off track of like really what you're looking at. So let's divide. All right. I have x squared minus 12x plus 25 divided by x minus 8. What is my dividend? Very good. The x squared minus 12x plus 25. Remember, dividend is the part that goes underneath the division symbol. What's my divisor? X minus 8. Okay? Now I am ready to divide. I've set everything up. You need to ask yourself, x times what gives me x squared? X. Or you can ask, how many times does x go into x squared? It's still just x. Okay? Does everybody see that? X times x is x squared, yes? Do we agree? So I'm going to put x above where the x's are. Line it up. Nice and pretty. So once we figure out that top part, remember we used to have to take that top and multiply it by the divisor. And we're multiplying it by the entire divisor. What's x times x? This should always be the same. And then what's x times negative 8? You multiply it by the entire divisor. And then you subtract. Isn't that what we did next? Was subtract? Now, you're subtracting that entire term. So that negative is going to carry over to not just the x squared, but also to the negative 8. So what I like to do is I pretty much just like to change the signs. Okay? That's what you're essentially doing. Change this, change this. What's x squared minus x squared? 0. What's negative 12x plus 8x? Negative 4x. So I subtract, and then I bring down my next term, just like before. Okay, so to recap, we asked ourselves, x times what gave us x squared? That was x. So then we multiply the quotient by the divisor. So we got x times x, which is x squared. X times negative 8 is negative 8x. Then we need to subtract that term, so we just changed the signs. Yes? Because that was the entire multiplication of the quotient and the divisor. You always change the sign of everything. Okay, so if it's 3 terms, you change the sign of every term. Before, when we just had this, and we figured out that was 24, we're subtracting that whole number. It wasn't like we were just subtracting the 2, we were subtracting the 24. We got to subtract the whole thing. Okay? Other questions? So, we repeat the process. What times x gives us a negative 4x? Positive, negative? Negative. So we're going to line it up, constants over each other. Then we repeat the process. What's negative 4 times x? Negative 4x. What's negative 4 times negative 8? Positive 32. And then what do? You change the sign because you basically need to subtract that product that you just got. So if I change the sign here, change the sign here, what's negative 4x plus 4x? 0. And then what's 25 minus 32? Negative 7. What is negative 7? My remainder. Because I have no more things to bring down, right? No more things. Let's check to see how well we did. To check, you take your quotient, multiply it by the divisor, and then add the remainder. So quotient times divisor plus remainder should equal my dividend. Oh man, this is insane. Here we go. What's my quotient?
I need to multiply that by my divisor.
X minus 4. I need to multiply that by my divisor. What's my divisor?
Then I need to add my remainder. What was my remainder?
X minus 8. Then I need to add my remainder. What was my remainder? Negative 7. How do you multiply these? FOIL. X times X. X times negative 8. Negative 4 times X. And negative 4 times negative 8. And then I have a plus, a negative 7. Plus and a negative make a what? A negative. Can I combine any like terms? What's negative 8x minus 4x? Negative 12x. And what's 32 minus 7? Is that my divisor? So we divided well. So now I need to write my quotient as a polynomial. Remember, it's your quotient plus or minus your remainder over your divisor. So the final answer is x minus 4. Since my remainder is negative, it's a minus. And then 7 over x minus 8. And that's your final answer. Well, since it was a negative 7, we made this out here a minus. Say again? It won't always be an x at the top. It really is going to be dependent on whatever the first term of your divisor is. Okay? What is the divisor in this problem? Number 2. X plus 6, so that goes on the outside. And then my quotient goes on the inside. I mean, not my quotient, my dividend goes on the inside. What do you notice about the dividend? It's not in order. Do not have that trip you up. Make sure it's in order, standard form. So it should be negative 5x to the third minus 24x plus 28x minus 48. My big handwriting is not allowing me to be great right now. Now, you always start with the first term in your dividend. X times what gives you a negative 5x to the third. Negative 5x squared. Okay? So I'm going to put that above the x squared, so negative 5x squared at the top. What do I do with that negative 5x squared? I need to multiply it by what? The divisor. So negative 5x squared times x is? And what's negative 5x squared times 6? Answer. Because we're multiplying the quotient by the divisor. So when we multiply negative 5x squared times another x, you increase the number of x's that you have. And now what do we need to do? Subtract it, which is going to cause us to do what? Change the sign. So when we subtract, this basically becomes a positive 5x to the third, and then this becomes a positive 30x to the second. And if you do it right, that first term should cancel out. Okay? So it does. That becomes 0. And then what's negative 24x squared plus 30x squared? 6x squared. Then we bring down the 28x down. And we repeat the process. X times what gives me 6x squared? So this becomes a plus 6x. And now I take 6x and do what with it? Multiply by the divisor. 6x times x?
6x
That works.
times 6.
Same thing. 6x times 6 plus 36x. And change the sign. And I'm changing the sign because of what reason? So the 6x squared can cancel out, and essentially we're subtracting these things. Okay, so they cancel out. And what's 28x minus 36x? Bring down the negative 48. Almost there. What times x gives me negative 8x? Negative 8. Negative 8. What do I do with it? Multiply by the divisor. Negative 8 times x. Negative 8 times positive 6. What do I need to do? And what do you notice? It cancels out. So I have a remainder of 0. And so just what's at the top was the quotient. I have no remainder, and that is my final answer. And it will work out that way. Sometimes you won't have a remainder. And that is okay.
So far, so good?
So far, so good? Do you guys want to try number 3 on your own? Okay, I heard more yeses than no's. So you guys are going to do number 3 on your own. There we go. All right. So this particular one, what is my divisor? X minus 4. And what is my dividend? And I need a 0 because of what? Placeholder. You guys see how there's an X term missing? Okay. Now, if you forgot about that placeholder, you lucked out because this one didn't hurt you any. But it could, okay, depending on elsewhere it's placed. But anytime you're missing a term, it doesn't have to be the X to the third term. It could be any one of those terms. You always plug in a 0. So, X times what gives me X to the 4th? X to the 3rd. Then I take X to the 3rd and do what? By the divisor. X to the 3rd times X. And X to the 3rd times negative 4X. Negative 4 to the 3rd. I almost gave the answer. I was able to stop myself. What do I need to do? Change the sign. So this becomes a positive. So then these cancel. 1x to the 3rd. Bring down the next term. Questions? X times what gives me x to the 3rd? X squared. A positive or negative? If you put a 1 in front of any of these, that's fine. It still works. X to the 2nd times x. And negative 4 times x squared. What do I need to do? Change the sign. And this becomes a. Everything cancels out. Okay? So basically I have a 0. I bring down the next term, which is 0x. X times what gives me 0x? A 0. So when I multiply 0 by my divisor, that just becomes 0. I bring down my next term because this is basically 0. When I subtract or add, it's still 0. Negative 6 is my what? My remainder, because x times nothing nice is going to give me a negative 6. So that's my remainder. I got to write it as a polynomial. That's x to the 3rd plus x squared. Do I really need to write that plus 0? I don't. Then I need to do my remainder over my divisor. So that's going to be minus 6 over x minus 4. And that's my answer. We're going to do number 4 together, and then I want you to do number 5 on your own, okay? They're on the back of this paper. All right, just to make sure that we're good. And then we'll also probably do like a couple on your desk. All right? Actually, we'll probably do both of these together. Yeah, it's just instead of being something that's like an x plus a number, or x minus a number, now there's a number in front. But doesn't change it doesn't change our processes. We still go through about it the same way. My divisor is 2x minus 5, and my dividend is 14x to the third minus 25x squared minus 43x plus 45. I'm not missing any terms or any x's, so I'm good, and it's in order.
So why did you have to put the 0?
Because we didn't even have that x term there. Like you see how we have a negative 43x? We didn't even have that last time. So we always want to make sure we put a placeholder anytime a term is missing. So this one's a little bit different, just because instead of us asking, x times what gives me 14x to the third, I have to ask myself, 2x times what gives me 14x to the third? 7x squared. Same. Okay? So this was a tad bit different. So anytime there's a number in front, it's almost like, 2 times what gives me 14. Okay? And then you just got to take care of the x's. So now I still do the same process. 7x squared times my divisor. What's 7x squared times 2x? 14x to the third. And what's 7x squared times negative 5? Then I change the sign. Negative 25x squared plus 35x squared becomes 10x squared. Right? Then you drop down to negative 43x. And repeat. 2x times what gives me 10x squared? 5x. What's 5x times 2x? What's 5x times negative 5? Careful. Negative 25x. Watch those signs, because if we get off on our signs, it's going to change everything. Now I need to switch the sign. We'll hold up for just a quick second, make sure everyone's still caught up. Those 10x squares cancel out. But what's negative 43x plus 25x? And then I bring down the 45. Okay. Thank you. Negative 18, right? And repeat. 2x times what gives me a negative 18x? Careful. Negative 9. Watch those signs. Watch those signs. So what's negative 9 times 2x? And what's negative 9 times negative 5? What do I need to do? Change the sign. So then what I'm left with is my remainder, which is 0. So my final answer? With no remainder. Okay. You all right? Okay. All right, let's look at the last one. We got a whole big old expression for this one. But it's okay. We can do it. Which one's my divisor? X squared plus 4x plus 3. And my divisor is x to the third plus 3x squared minus x minus 3, right? No missing holes? Oh my gosh, that's probably going to be the easiest one. Because think about it. You still start off. X squared times what gives me x to third? X. So I'm already over here. I'm already like pretty much almost lined up. Okay? So x times x squared gives me x times 4x is and then what's 3 times x? 3x. What do I need to do? Of every single one. So this becomes a, this becomes a, this becomes a. So the x to the thirds cancel out. But then 3x squared minus 4x squared is a negative x squared. Negative x minus 3x. And then I bring down the negative 3. And I repeat, x squared times what times x squared gives me a negative x squared? A negative 1. What's negative 1 times x squared? Negative 1 times 4x. Negative 1 times 3. And I have to change the sign. And I just get 0. So x minus 1 is my answer. Nah. I mean, probably if we're creating it, we probably are going to make them kind of nice and pretty like that. But if you try like to Google like longer, it could be something kind of crazy. All right? So remember, you can always check your answer by taking the quotient, multiplying it by the divisor, and adding the remainder to see if you get the dividend. Okay? So go ahead and get these pages glued down because we're done with dividing by polynomials by long division, but I want to make sure that we still practice, okay? I'll make sure that you guys got this, so practice a couple before I give you out your homework.